Okay, so implementation of a security policy, once you have identified what you want and also defined requirements for it, is actually a critical step towards achieving information security. And I love this quote as a good way of introducing the implementation phase. This is Spafford's Law of Security. If you have responsibility but no authority to make changes, you're just there to take the blame when something goes wrong. I think that is absolutely the case, and implementation is typically where that most often happens, implementation or incident response. So who are the people who are doing implementation? Well, the roles that you're going to look at: users, project leaders, and managers. Those are probably the most obvious ones. Database administrators are in many cases responsible for access to and integrity of a database, and that makes a big difference in a security context most of the time. So database administrators need to be included as well. And then the ones that are pretty much the public-facing folks, the information security officer, the CISO, and all of the managers in that whole organization. They're typically responsible for overseeing the creation and implementation of these policies, including retention and disposal of information that's sensitive, right? Customer information, healthcare information, financial information, that sort of stuff, depending on the domain that your product is operating in. And then personnel staff members, typically the people who are involved in the employee onboarding process and training programs for internal security mechanisms. So these are like roles that you would find at any organization that has an information security concern, each of which would probably have to be filled by more than one person in order to be reliable. Right? You want to make sure that it's more than one person who's capable of making all of these decisions, in part because you never want your organizational security posture to be compromised by somebody having a surgery or some personal issue that prevented them from being able to take part in discussions. Implementation also requires a timetable, and a plan for maintenance. This is not something that you want to put off until later. It should actually be built in from the very beginning. The plan really needs to look at the order in which controls are implemented, including the prioritization of the most serious exposures so that they're covered first. The plan also has to be extensible because you're probably going to end up with new equipment, new features, new connectivity, new threats identification, new threats being identified in the future, and you want to make sure that all of this stuff is something you can include in your implementation procedures. You especially want to have procedures for changing existing components of the system because that's the kind of thing that's just inevitable. Like software inevitably has to deal with requirements change, and even after you've specified the requirements for the system, you still have to continue doing requirements analysis and adjustments related to features that you thought were pretty solid. Simply because change is inevitable. And of course, that means a periodic review for the plan as a whole, including the requirements that you'd previously done analysis for. That's one of the main reasons why all of the requirements analysis stuff and risk analysis stuff that we talk about in this lecture is so important. It's not so much that you have to get it right the first time, it's that you have this periodic review period where you're going to continually go back and reevaluate your current plans. So high-level flowchart of all the things that we're interested in doing. You have to have security policies, all the constraints. This is kind of a critical component. The requirements that we were just talking about, and then the techniques and controls and mechanisms that we've been talking about most of the semester, all of those security techniques, they all go into the planning process, and eventually, at the end of the day, you come up with a security plan. Quite a lot of security planning is really just collecting and gathering inputs. It's not all that different from data science. You're trying to make an evidence-based decision, and that requires collecting evidence to support the decisions you eventually plan to make. Making sure that you've documented this is important, not just because you want to have a documented plan to do implementation, but also if there is an incident, you need to be able to go back to the plan and do a post-incident review to figure out what of these inputs did we miss when an incident occurred that caused it to be so dangerous for our own organization. Okay, so who would be on the planning team? This is different from the implementation roles, in part because the team that's doing the planning is actually going to have to be more representative of the technical components, right? If you look at the implementation roles, we're including users and personnel, staff members, people who may not actually know very much about the technology involved in security. But the planning team members, they have to be a little bit more technically oriented because this planning is going to touch almost every aspect of the engineering within your organization, and will probably require implementation. Will probably require representation beyond just the security group that we were talking about earlier in terms of technology. So a common approach to planning, this is just a common approach that may be different for your organization, it may be different for particular domains, but a common group, you're going to look at hardware, you're going to look at software administrators and programmers. You may actually have end-user application programmers or third-party application programmers that you have to look at and include in your security planning model. Data entry personnel, depending on your organization. Some of this is actually being replaced by automatic data collection. Physical security personnel. Remember, very early on in the semester, we were talking about physical security as an unavoidable part of the software security process as well. This is where you need to include them in the planning. And then, of course, someone who can stand in as a representative for the user. Ideally, you would want to have a knowledgeable user, somebody who's got some skin in the game, right? That you could include in the security planning team. And again, I'm just stressing this is a common list. It doesn't necessarily mean that this is going to work for everything. And there are probably organizations that would need to include people who are not on this list. It really does depend on the organization, its history, and incidents that it's seen in the past. All right, so once you have a security plan, it's important to try and find a way to commit to the plan in a meaningful way. A plan with no organizational commitment is just going to collect dust on a shelf somewhere and eventually be used to assign blame after an incident happens, right? This is why Spafford's Law is so important here. There's probably a corollary to Spafford's Law where if somebody's not actually committed to the security plan, it's because they want to blame the people who are committed to the security plan. So make sure everyone is on board and agrees to the security plan before you start implementing things, before you start moving forward. And three groups in particular are really critical to making sure this is successful. The team that came up with the plan, the planning team, has to be sensitive to all of the needs of users and people who would be affected by the plan. That's why you want a user representative, for example. Everybody who's going to be affected by the plan, meaning they have to build something to comply with the security recommendations or they have to not do things in accordance with security recommendations, they need to understand the plan and why the plan has been put in place. In particular, you want to make sure that they have some ability to understand what effect they will have on the plan if they fail to comply with it. And then finally, you have to have high-level management commitment in order to make sure this happens, because enforcing security on a system generally means somebody else is going to lose some kind of convenience, and unless management is behind you on that, it's going to be very, very hard to get buy-in and commitment to the security plan. Continuity planning is a little bit different than pure security planning, but I want to mention it here. Again, this kind of goes back to something we've said in pretty much every single lecture in this class. Backups are an incredibly important part of information security. If you have only one thing that you can do to prepare for a security incident, it is make sure that you have a great backup system in place. But even in that scenario, backups can fail, and they often take time to deploy, time that you're never going to get back again. So it makes sense to have a plan in place for incidents like this to get you through the actual immediate aftermath of the incident. And that's what continuity planning is really all about. Business continuity plan will document how the business will continue to function. Part of that includes security continuity planning for information systems that are part of the business, critical part of the business in many cases. So you really want to look at two things, both the catastrophic immediate scenario where something major happens all of a sudden, and then the sort of long duration incidents where there's a somewhat minor concern that's expected to last for a very long time. Otherwise, businesses will suffer. So a good example of that is actually the coronavirus that we're dealing with right now. Information security has changed as a result of the coronavirus. And if you follow security professionals on social media like Twitter or Reddit, you can see just how big of an impact this has had, because it is a long duration during which all of the security assumptions that organizations had about bring your own device policies and what equipment their employees will be able to use, who constitutes an insider versus who is just a stakeholder should be considered external. All of those assumptions have changed somewhat, and so therefore the security response has to change in relation to that. And this is going to happen for probably the next year, 18 months, maybe longer, kind of depends. But that's why you have continuity plans for information security. Some of the activities in building a continuity plan include assessing the business impact of a crisis. This is true for both the short-term catastrophic incident and also the long-term one like we're dealing with now. Essentially, identifying your essential assets, making sure that they don't really change after the crisis has happened, and then making sure that you understand how disruptions to those assets will affect the business in the future. You want to make sure that as a part of your continuity planning, you have a strategy to control the impact to the best of your ability, and that includes the safeguarding of key assets. Right? If you don't know what your key assets are, it's really, really difficult to protect them. But even knowing what they are doesn't necessarily mean that you can protect them. You still have to have a plan in place for safeguarding them, and that continuity, that part of your continuity plan is really, really critical. It's also important to implement a strategy for identifying who's in charge after an incident occurs. Right? Sometimes that may change, or based on necessity, you'll have to have some kind of a chain of command or a chain of decision making in the case that some of the people who would normally make decisions about incidents are incapacitated or unable to make an assessment. So this includes the who, what, and then of course the implementation of those the things that you've identified in this what phase. Who actually has the particular tasks that need to be carried out.